This is lesson 22, day 2. We're going to do the solving and graphing the absolute inequalities. So we have two different examples here of inequalities that have absolute values in them. One of them has a less than symbol and one of them has a greater than symbol. They will mean different things. Their solutions to these actually are slightly different. Now, here's the cool thing, is that having absolute values, just like we did yesterday, we can isolate absolute values as if it's a variable or something, a parentheses. So it's kind of acting like a parentheses, we'll say. I got to get that grouping symbol, that absolute value symbol, by itself first before I can get rid of it. And we're going to get rid of it again here in these problems, like we did yesterday, like we have right above, saying that you take the absolute values away, it's equal to the positive, and you have to set it equal to the negative, right? Value of C. That same idea is going to be used here, but we have an inequality symbol. So they're going to be slightly different. So if I had to isolate, in this case, the absolute value of x minus 2 is less than 2, how can I isolate the absolute value to itself? Add 2. Oh, not x. Add 2 to both sides. And we get absolute value of x is less than 4. You guys agree with this?
Yeah.
Now, before we even solve it or break it or get rid of the absolute values, let's look at things that would make that true. What numbers, when I take the absolute value of it, is going to be less than 4? 3. Absolute value of 3 is 3. Is 3 less than 4? Yeah. 2? 1? 5? No. So 4 is kind of the top, but is 4 included? No. But anything less than 4, right? Because it says less than 4 should work. So 3, 2, 1, 0, 1.56. That's fine. So decimals and everything in between. 0? Absolute value of 0? Is 0. That still works. Negative 1. Negative 2. Negative 3.
Yeah.
Negative 4.
Nope.
No. Absolute value of negative 4 is 4. Is 4 less than 4? No. Negative 5? No, because all of a sudden those numbers start getting bigger again. Oh, okay. So wait a minute. So if I was trying to figure this out, that means it starts someplace and it stops someplace. So what we find is that there's an upper bound and a lower bound to this problem that all the solutions fall within. And so this is what's going to happen. We said, wait a minute, couldn't I just take away those absolute values? And we said, hey, it was all values, right, that just happened to be less than 4, right? But then we also started going down the list, right? 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. And we said, wait a minute, now we just lost again, right? Can't do that. So we found out that those numbers have to be bigger than what? What's the smallest number that can go into this that works?
Negative 3.
Well, negative 3 works, but there's still more than that. It all the way goes up to, but not including negative 4. Because it can't be negative 4, but I can be right up to it, right? Just like 4. 4 is really not included, but I can be 3.9999999 as many times as you want. Just like negative 3.99999. So, that happens every time. I'm hoping everybody could make this on a number line. Negative 4, 4. What kind of dots are there?
Open.
Both are open dots. Where is it shading? In the middle. How do you know?
Because that's where everything is.
Because we listed off all of those points that worked, right? But how I like to do it is I like to check a point. What's in the middle that's really easy to check? Is 0 between -4 and 4? Yes. So I shaded in. Therefore, you've graphed it. We solved it. We found out that it should be the solutions between -4 and 4, and we graphed it. Guys, what do we think we could use as a rule on this one? I'm going to go back up to the top where we have our ax plus b, the absolute values. Ax plus b, absolute value, okay? What if I said that that was less than c? I'm even going to go as far as less than or equal to. Whatever that sign is, it just follows along in the problem. But what do you think the rule is going to be on this one? What is it going to break down to? What did we do with the 4? Did we change the x inside? No. So it's still going to be ax plus b. Half of the problem, guys, half of the problem is dropping the absolute value and saying it's still less than or equal to that value, yes? But then we said it was also going to be bigger than or equal to the opposite of c, or negative c.
That'll always happen?
That'll always happen with an absolute value inequality.
We have positive, negative, 8.
Yes. Okay, so the other one. The other one's already been isolated for us. What should we do here? What kind of values are going to be greater than 2 when I take the absolute value? If I'm just looking at values itself, what if I change the problem? Well, I'm going to change it real quick. We can go back to this one. What if I just said the absolute value of x is greater than 2? So let's ignore this. You know what? Let's just ignore it in general. What if I just said the absolute value of x is greater than or equal to 2? Give me some values.
3.
2 does work this time, because the absolute value of 2 is 2, and 2 is greater than or equal to 2. Negative 3? Negative 3, guys. Absolute value of negative 3 is 3, and 3 is bigger than 2. 3, 4, 5, 6, 7. Negative 2, negative 3, negative 4, negative 5, negative 6. All work. How about 1?
No.
Oh, 1 doesn't work. So wait a minute, wait. So if I was on a number line where I would have 2 and negative 2, it seems like those both worked, right? And they were included. 2, 3, 4, 5 went this way, yeah? Could I be 1, 0, negative 1?
No.
No. I could be negative 2. Could I be 3, negative 4, negative 5?
Yeah.
So it went this way. You guys starting to remember seeing these types of graphs?
Yeah.
Either they went towards each other or away from each other. So, wait a minute. What does this mean? How would I write inequalities for those ones? X is less than or equal to negative 2 for the left side. Or x is greater than or equal to 2. Can you guys agree that those inequalities would be represented on the graph there?
Yes.
That is what's going to happen. Now, wait a minute. Just like yesterday, just like we did over here, if I remove the absolute values on the absolute value of x is greater than or equal to 2, doesn't that automatically give us half of the problem? It did it above. It gives us one of the options, right? Way up here, it gave us one of them. Down below, it gave us half. We just didn't have the other half. And so the other half always seemed to be taking c and making it negative. But here's the problem. I'm working with inequalities. If I'm changing or multiplying things by a negative, what's going to happen to the sign? It's going to flip. So when I multiply that second one, this second group here, the sign changes and then it has a negative 2. So let's come up with a rule. So the rule states that if I have that absolute value inequality this time, ax plus b, and we find out that it's greater than or equal to c, okay? Now it's changed. Now it looks like the top, but a little bit more generalized. You have to split it. And again, one answer is the same thing, just drop the absolute values. That inside part, sorry it's going into the watermark there, is that one part is just the inside, ax plus b is greater than or equal to c. Just drop the absolute value. You have half the credit, you have half the problem. Then you also have to go back and put or the ax plus b, flip the sign, so it's less than or equal to negative c. Okay? I'm going to move the or over just a little bit. So, what happens is that if you have absolute value inequalities, you have to eventually make negative c still, but you have to sometimes flip your signs. Okay, guys, this was the original problem or example that we had there, and I switched it. So let's actually approach this problem. Okay? We notice that we have an absolute value inequality greater than or equal to 2. And so I'm going to use the fact that I'm going to just drop the inequality, right? Half the problem says this, yes? And then you put or. I say x minus 5, whatever's inside is what? I have to make it a negative 2, but what about it?
Less than or equal to negative.
Less than or equal to negative 2. And solve them individually. Well, to solve them individually, I use the same approach, which is adding 5. So x is greater than or equal to? 7. Or add 5. Add 5. X is less than or equal to 3. Not negative 3, I'm adding 5, so it'll be 3. So when I go to my number line, where are my anchor points? And this makes a difference.
7.
It's 7 and 3, but make sure you put the 3 where?
On the other side.
You put them in order. Are these included or not included?
Included.
They're included, so they're solid dots. Where is greater than 7? Going to the right. That way. Not necessarily. Be very careful when you say that.
3 is like less than x.
Yeah, then it would be the other way. So be careful. Don't always just assume that it's in the right notation so that you can say the arrow points the right way. And x is less than 3 going this way. So you've solved it. You've got the inequalities here. And we graphed it. Homework is on page 163, problems 1, 4, 6, and 23. Have a great day.